Okay, welcome everybody. We'll make a start. I think people are going to continue streaming in as they get their lunch, but we will make a start. My name's Sean. I'm the CTO at Bankwest. We're very, very proud to be associated with DDD since the very first one 4 years ago. I'm absolutely blown away by how much this conference has grown from about sort of 80 people down at the Swan River Rowing Club, I think it was, down in Burswood a few years ago. To see it scale to 500 people here today, the amount of engagement, the quality of the speakers, hats off to Rob and all of the volunteers who've helped put today together, because it's been a phenomenal conference so far. At Bankwest, we're undergoing our own revolution. We've just implemented a bank-wide revolution towards agile ways of working. End to end, the whole bank has changed its operating model. We're also undergoing a technology-driven revolution where we're building a new technology stack. And luckily, we've got Mike here helping us plan our migration onto our new technology stack. I met Mike about 3 months ago in London, where I heard him give a talk about software revolutions and DevOps and continuous delivery. So we flew him over here to come and give us a hand. And very luckily, it coincided with DDD. So we're able to get him to give his talk today. If you want to hear more about Bankwest, we've got our Orange Grove out the side, which is manned all day, and you can come and speak to people about what it's like to work at Bankwest, what we're doing in the technology space, and the only criteria is you must like orange or oranges, and we're serving fresh orange juice there all day. But yeah, I'll hand over now to Mike, who's going to give his talk on how software revolutions happen. Thank you.
Thanks, everyone. Is this on? It's working? You can hear me? I hope not. There we go. We're live. So yes, hi everyone, I'm Mike. I want to share with you something I'm really excited about. It's a little bit about why I think Agile represents a new paradigm in software, and also why DevOps and continuous delivery are instrumental in that story. The idea, thank you to all of our sponsors, aren't they awesome? So the ideas for this talk really came from, and were inspired by this book. This is the Structure of Scientific Revolutions. It was written in the late 60s. It was Thomas Kuhn wrote the book. At the time, Kuhn, he was studying for his PhD in physics, but he also happened to have to teach a course on the history of science as part of his duties at the university. And what he realized from teaching this to the students was that the way that we teach and understand science and the way science is moving forward is completely different from the way it actually happens. And instead of science being some kind of incremental journey towards finding the truth, what happens in actual fact is that we go along in these paradigms. It was this book that first kind of came up with the term, the paradigm shift. So scientists were operating in a paradigm until they had a big revolution and they had a new paradigm. And this was the normal way of scientific progress. So this is the Popper method. This is how we're generally taught at school and universities, that this is how science works. We make observations, think of interesting questions, formulate hypotheses, develop testable predictions, run the tests, figure out what we've learned. This is the scientific method, right? This is what we believe is science. And it is kind of true. It is kind of how things work, but it's also not actually how we've progressed through history. What Kuhn says is actually what we do is we go through these revolutions, and our scientific fields are reconstructed from the ground up through each of these revolutions. We have new fundamentals. So this is Kuhn's cycle of the revolutions. Normally, we're going through this normal science, which does actually look quite like the Popper model. It occurs within a worldview. This was what really is the paradigm. We all share this common worldview. And what science is trying to do in this phase of the field is to bring nature and theory into closer agreement. This is what scientists are doing. The thing is that during a paradigm, scientists take the foundations of their field for granted. They don't have to rewrite textbooks. The university literature is sound. There is a method for growing within this field. And most importantly, you generally get the results you expect to get. So when we did the Large Hadron Collider and did the experiments, we found the Higgs boson. This was the result we kind of expected. That's why people spent money on the experiment in the first place. Same with Dolly the sheep. Let's try and clone a mammal. Well, they cloned a mammal. It's no big surprise. It's an achievement for sure, and it's bringing science forward. But we're not really falsifying hypothesis. We're actually getting the results we expect. The thing is, though, when operating in a paradigm, paradigms and science is never correct. We're not finished with science. And what happens is all these sometimes anomalies start to crop up. They don't fit into the worldview. And it doesn't make sense. And some scientists start to question whether we have the right foundations for the field. But importantly, even if there are things that don't fit into the field, people will hold on to the paradigm because that's the foundation of their field. They will not give up the paradigm unless there's another paradigm to replace it. If enough anomalies crop up, eventually the field gets into a state of crisis, and people start to think really outside of the box, starting to question the fundamentals. There's a lot of discontent and fighting and arguments in the field. Now, the only way to get out of a crisis is through a revolution. And to get a revolution, you need a new theory, a new foundation for the field. And this new theory will completely wipe away the previous paradigm and theories that we had in the old paradigm. And the old paradigm is completely replaced. And then we get this paradigm change or paradigm shift. And it follows the Highland pattern. There can only be one paradigm in a field at a time. And older views are simply read out of the profession. People who hold on to the old worldview are no longer relevant in the new field. So I hope you can start to see that this can be quite similar to a lot of the history of software. So there we go. We go through paradigms, one paradigm to the next paradigm, and it seems messy, it seems wrong, but this is actually the normal pattern. This is how science progresses. It's not a bug, it's a feature. We do the progress we can in a paradigm until it doesn't fit, and then we cast it aside and find the new one. This is how science progresses. Just to make it a bit more concrete, there was a time when we all believed that the world was the center of the universe. And it made perfect sense because we're standing still, obviously, and everything's flying past us. There goes the sun, there goes the moon, there goes the stars. This is normal. But Copernicus and Kepler, well, they were thinking, wow, this doesn't really fit. It doesn't fit what we're seeing in the sky. Something's not right. And so they came up with this new worldview. It was like, instead of geocentrism, we had heliocentrism. So yeah, maybe the sun is the center of the universe. Doesn't that make more sense? It's not quite the right answer either, but it was a step in the right direction. 50 years later, we had Newton coming up with some interesting thoughts. What if the way that the planets move around the sun operated in the same model as the way a ball flies through the air? What about if these equations were general? What about if we had a general law of gravity? And this was important as well because this was the first time in history where we started to understand that there wasn't different laws for the things that happened in the sky. The celestial bodies had the same physics as the things on Earth. And actually, Newton's laws served us very well for quite some time. And then eventually we got Einstein coming along thinking, well, maybe it's not space and time that's fixed. Maybe it's the speed of light that's fixed. And speed and time are kind of squirrely. So that's how, for example, physics has been progressing through successive revolutions. Then we had quantum field theory, and it's going to continue. It's just going to continue. This is how we make progress. Now then, how does this map into software? Well, software is a much younger field. You could go back to Babbage and Ada Lovelace, but I think it really started with Turing and the Turing machine. So this was the late 30s, where Turing is starting to talk about the Turing machine. And it was only 30 years later when we had our first software crisis, and it was called the software crisis. This was an open discussion amongst the academics and leaders in the field. And Dijkstra says it like this: as long as there was no machines, programming was no problem at all. And then we had a few weak computers, programming was a little bit of a problem. And now we've got gigantic computers. Remember, this was 1968, so they were truly massive. They started to have gigantic problems, and they understood that they couldn't continue the way they were going. Now, they also had an idea for the way forward, and where he said this, where this quote comes from, is an indication of what they thought the solution was. This was at the NATO Software Engineering Conference in 1968. What Dijkstra and the other leaders in the field thought at this stage was, we're going to engineer our way out of this problem. We're going to start to adopt principles and practices from engineering, and that's going to get us forward. This is going to solve this big complexity headache we've got. So that's what we did. We pretended like we were civil engineers building bridges. We made plans. We did estimations. Otherwise, how are we going to know how much the project's going to cost? Then we start to do some design and break it down and decompose the problem. And this was the era of what I call the engineering era in software. And that took us from the late 60s to, I'd argue, the late 90s. And it was phenomenally successful. Everyone bags on waterfall and old ways of doing things, but people forget how much progress we made in the software field between 68 and 98. It was massive. The thing is, it didn't last, right? We all know it didn't last. Eventually, the anomalies started to pop up, just like in science, right? The anomalies started to pick up. This is a great page on Wikipedia, one of my favorites. I think it's my favorite Wikipedia page after the list of cognitive biases. This is a Wikipedia page on software failures, projects that have failed in software. Now, this is a small section of part of that page, which is about permanent failures. Basically, projects that failed to deliver on any of their outcomes or any of the values that they were expecting to get. One of them that's particularly close to my heart is in the middle there, the NHS for Connecting Health. Do we have any British people in the audience? Right, so you probably have heard about this too. Maybe some of you were on this project, I don't know. But here, it cost the taxpayers £12 billion. £12 billion. That's like $20 billion, I guess, something in that ballpark. Could you imagine that amount of money? I mean, that's a lot of Apple stock. It's really a lot of money. And that project failed to deliver any value. Now, I'm pretty sure that they followed all the good engineering practices. I'm sure they had estimates. I'm sure they had a plan. I'm sure they had architects drawing good documents. I'm sure that they followed everything down to the letter, and all of the suppliers were CMI level 5. This was not a failure of process that this project failed. There was something else going on. There was other kind of anomalies cropping up too. There was open source, GNU, Linux, and different ways of working like XP, which were showing how you could succeed without following any of that engineering nonsense, without having requirements, without having design documents, without being co-located, using volunteers. There was all kinds of ways you could make software that didn't fit this engineering practices, and they scaled to very, very large projects. So we had these two kinds of anomalies really starting to creep up, and they're coming to a head during the late 90s. And we have this crisis, and a lot of the leaders in the field at this stage are saying, well, hold on, maybe we've got the wrong idea. Maybe we've got the wrong paradigm. Maybe we have the wrong fundamentals for our field. What if, just what if, we're not civil engineers making bridges? What if instead we're working on the factory floor making Toyotas? Wouldn't that be a different story? It's a lot less glamorous, isn't it? But it's maybe closer to the truth. So Eventually, these leaders who were more or less arguing through all the 90s about the best way to make software got together in Snowbird and figured out, well, at least there were some things they could agree on, and they got the Manifesto for Agile Software. And this was quite revolutionary at the time. A little bit later, it required some more information because the values of the manifesto weren't enough for people. So a little bit later, they came with some principles behind the Agile Manifesto. The very first principle, and they also state the highest priority, is to satisfy the customer with early and continuous delivery of valuable software. Now this is 2002. What we have here is a theory that if we can satisfy the customer with early and continuous delivery of software, it will lead to better outcomes. This is a theory. It sounds good, but at the time there was a lot of pushback. People found it hard to give up the old paradigm, but still, we had a theory. The thing is, a theory is not enough to get a revolution. If we go back to Kuhn and the structure of scientific revolutions, you can't get a revolution just with theory. You need achievements too. And the achievements must have to be sufficiently unprecedented, something that could not have been done with the old paradigm. And secondly, they have to be sufficiently open-ended. And that's because in order to get to spark a new paradigm, a revolution, you need to get people in your field into it. Now, smart people are not interested in solutions. And I know you're all smart people. What we're interested in are problems. We get attracted to problems because we want to go and solve problems. That's why we do what we do. So we needed unprecedented achievements and open-ended problems to solve. I think part B was solved at the stage of the Agile Manifesto, but there wasn't any really big successes with Agile for quite a while, actually. And I would say it wasn't until we started to see what I guess we could call the second growth of Silicon Valley, when we started to get a lot more companies having what I guess we'd call unicorns these days, having great success at delivering software continuously and frequently. And I think Flickr was at the vanguard of this when they were talking about 10 deploys per day at the Velocity conference in 2009. And very shortly after that, we got this term, DevOps, and DevOps days. And we started to get more and more literature, the Phoenix project. There was a lot more success. People were having great success by following these Agile Manifesto principles. So we have a theory, and we start to have some achievements. We've still got a lot of problems to solve. Part of the problems we have is that we don't have the tools to do continuous delivery. Continuous delivery is a great idea. We can write it down in a manifesto. But how do we actually deliver continuously to the customer? It requires an awful lot of tooling. And the good news is that as software engineers, we love making tools, sometimes a little bit too much. We can see that the same story played out in software. Without the telescope, we couldn't have Kepler's tables, and we wouldn't have been able to get Isaac Newton's principles. It's just simple as that. You need the tools plus the data to get the theory. They all go together. Same thing with evolution. If we hadn't been able to make ocean-going voyages, if we didn't have the expedition where Darwin went and collected all the data and started to see the differences between different islands, we would never have had the theory of evolution. Now, it doesn't need to go in that order. You don't have to have the tools and the data to capture the theory. Sometimes you get the theory first, and that's especially true in physics, because physics you have applied and non-applied physics, experimental, and so on. So the Higgs mechanism was actually postulated in 1964, and it was almost like 50 years later when we actually got anywhere to proving it. And that was because we didn't have the tools or the data. But with CERN, we got the Large Hadron Collider, we got the tool, and then the experiments produced the data that actually proved that the Higgs field was there. So we need tools and we need data to be able to sustain a theory and get that revolution. We have a telescope, we've got the Beagle expedition, we've got the Large Hadron Collider experiments. Now, Agile has this theory. The theory is that Agile approaches, Agile practices, will improve your business outcomes. But where are the tools to help to implement that? And where's the data to show that that's actually true? There's at least in the first decade of this century, there was mostly just anecdote at this stage. But as software engineers, we started building tools. We started to understand that there's a lot of things in continuous delivery that we can automate. And more or less, everything that happens after you're done with your work to it being delivered to the customer should be automated. Right? You don't want to be building your software manually. You don't want to be testing your software manually. You don't want to be producing your documentation and your compliance manually. You want to have that all like as a fixed, steady, repeatable process. And we built lots and lots of tooling around this. Ideally, you can think of any technology organization as some kind of meat machine whose purpose is to take customer or business needs and deliver them. It's a change delivery organization. That's why technology organizations exist. So everything you can do to make that smoother and use the tooling is a good investment. So, quick question, how many people are using some of these tools? Right, nearly, I guess all of you, right? And I'm sorry if there's any COBOL people here. But, I mean, the other good side of being a software engineer is that we're not only good at making tools, but really good at adopting them. All of these tools, I think, maybe, yeah, in the last 10 years. All of these tools were made in the last 10 years. I think that's a true statement. And I think that nearly every software project is using some combination of these tools at this stage. So we're good at this. We're good at retooling. And of course, we have to change a little bit as well. We need to get everybody in the teams. We don't want to have silos and so on when we want to automate. Good. So we have the tools. We can adopt them. But where's the data? We need to back this up. We can't just pretend that we know what we're talking about. Thankfully, there's been a lot of work over the last 5 or so years by the DevOps Research and Assessments company, led by Nicole Forsgren and Gene Kim and Jez Humble, sorry. And they've been doing an awful lot of data gathering. And they do an annual survey of thousands of IT professionals. Have any of you participated in this year's survey? Yeah, a few. So this is really important for our industry because this is the first kind of steps towards us becoming more professional in what we're doing. It's about gathering data from our industry to see what's working and what's not. There's a lot of talk in conferences about what's working, what's not. I tried this, you tried that. It's fine, we're getting a lot of ideas, but at some stage we need to get some numbers and see what's working and what's not. So with the State of DevOps report, what they're doing is they're taking all the data they're getting from these survey responses and they're publishing it for free in a report. But the most important thing is that everything about it is based on rigorous scientific method. Of course, what they're finding is that there's a big difference between IT organizations. There's high performers and low performers. Is anyone surprised by the fact that there's high performers and low performers in IT? No, I'm not either. But equally, what's fun is that they give you some real numbers. So you can see where on the performance kind of spectrum your organization is falling and what you should be focusing on to get there. Now, this is the most, shall I say, for me, this is the most important aspect of the State of DevOps report. It's about 50 pages. And this is the one diagram in it which I think is where the guts of the value are coming out. Because what this is showing is from their data, what is predictive of financial outcomes in an organization. So let me just simplify this a little bit. So over on the far right, it's all about the money, right? What are the financial outcomes for the business in terms of like your organization, your company, how did they perform on the stock market last year? That's how they're correlating, or actually more than correlating, they're associating financial outcomes with IT performance of a company. So what they found is that there are two key things that are predictive of positive or negative financial outcomes, and that's whether your company is adopting lean product management practices and whether you're able to do continuous delivery, or to the extent at which you're doing continuous delivery. So those two things in your IT organization are actually predictive of financial performance of your company. Now that's important. That's the first very, very important outcome from this research. The other thing is that it goes more into the individual practices and that are required to get there. And what they found, of course, is that if you don't have transformational leadership at the very foundation of all you're doing, then none of the rest will happen. If your leadership team isn't behind lean practices, isn't behind developing technical excellence, adopting practices and tools to make your organization excellent technically, then you're going to struggle. Now, you don't have to survey thousands of people to figure out what you're doing, where you are, and how you're improving or getting worse. Some very, very simple things. Actually, there's four key, if I go back here, there's four key, shall we say, IT metrics that are completely predictive, not just correlated, but predictive of business performance. And that's your deployment frequency, how often you can make changes to production, the lead time for changes. Once a change is ready, how long does it take to get to the customer? Your mean time to recover. We all fail, but how long does it take you to figure it out and recover from it? And then your change failure rate. How often does something fail in production when you change it? So only those four metrics, they're the only four metrics you need to capture to understand your IT performance. And these are the ones that you should be optimizing for if you care about performance. Now, of course, you need to go through a lot of these other practices to get better at those numbers, but at least those four numbers are shown to be predictive of financial outcomes. Very simple one. You can measure most of those. Actually, all those four measures can be measured from your incident system, your CI deployment system, and your task management system. You probably already have this data. You just need to find a way to get it out and monitor it. You can even just do it manually once a month. That's good enough. One thing that I find is very important is that most of us, is there anyone in the room that's not a developer? Right. So I'm going to speak to the developers for a second. Because what I find is that if you take a value stream from a customer need to it being delivered, developers are in a very, very small box. There's a whole bunch of stuff that happens before the work starts, and there's a whole bunch of stuff that normally has to happen afterwards. And this is especially true in regulated environments. So you need to get, you need to start to think about your whole value stream. Get everybody that's involved in your software delivery chain, your IT operations, your compliance, everybody, get them all involved and map out your full value stream, because there's no point in doing local optimizations. It's not going to help. You need to think about the whole. Right. I know I'm running a little bit late, so I just want to wrap up real quick with a couple of thoughts to take away with it. The first is a fantastic book by Andy Grove. Now, Andy Grove was the CEO of Intel. He's considered to be one of the best tech leaders of all time. He took Intel from being primarily in the memory business to being primarily in the CPU business, and that required completely changing the organization. It was a real transformation, and this book tells that story, Only the Paranoid Survive. Now, in the book, he has this very, very key idea about the strategic inflection point, where we're starting, if he'd stayed in the memory business, you know, it was getting eaten and eaten and eaten. The prices were going down, the competition was becoming fiercer, And frankly, the Japanese manufacturers were making better and cheaper memory than Intel were. And he understood that if he kept fighting in that fight, Intel would no longer exist as a company. But what he also saw was that if we have a chance now to get onto the next technology, and that was CPUs. And they did that, and Intel became phenomenally successful because of it. But it was an extremely hard journey. So this idea of strategic inflection points is really important. And I think that digitalization of traditional industries traditional industries are facing similar inflection points where banks, manufacturing, healthcare, insurance, they're all facing these same problems because those that are digitalizing and getting good at it are doing much, much better. So the future is here. This is good news. There's lots of people who have already done a lot of the hard learning. You don't want to be the first to adopt stuff. Don't run Istio in production just yet, for instance. You definitely don't want to be the last to adopt either because your company's probably going to get out of business. You want to optimize for throughput, plan for replaceability, and learn from the community. Come to events like this, learn and find out what other people are doing. So, yeah, that's it. I think that DevOps does define our paradigm. I think that there is a state of consensus that Agile is the theory that is the foundation of this new paradigm. Nobody's going back to civil engineered approaches to software development, unless you're making software for missiles and so on. Maybe you want to do that. But for everyone else, nobody's going back. We're only going forward. So Agile is the theory. DevOps, continuous delivery, are the practices that underpin it. And now it's time to prove it and show the value of these changes by gathering the data, adopting the tools, and getting really, really strong in our technical excellence. So yeah, science, it works. Thanks very much for giving me your lunch break. And if you have, we have no time for questions, unfortunately. But I'll be around all day and at the after party, so if you want to talk more about any of these ideas, please come over and talk to me.